Okay, before we actually start, I want to remind you of something that I think is kind of cool. So we know Pythagorean theorem, right? A squared plus b squared equals c squared. Again, c is the hypotenuse. But let's talk about what that squared means. Squared literally means a square. Okay, so in other words, if I were to draw squares out of each of these sides, so here is side A, and I would draw a square, 120 by 120. And here's side B, 50 by 50. Side C, 130 by 130. If I were to literally draw a squares out of them, this area, right, is equal to this area plus this area. So again, if I add the two areas of the legs sides, that equal to the area of the hypotenuse side. That's what this literally actually means. So taking a look here, it wants to find the length of the hypotenuse here. It's a piece of tile, right? 6 by 6, and it wants to know the distance across the middle there. So we would literally say 6 squared plus 6 squared equals c squared. Well, that's 36 plus 36 is 72 equals c squared. You grab your calculator, square root of 72 is 8.5. Approximately, right? Technically, it's the square root of 72 because we know this is an irrational number. So again, it's about 8.5 inches across there. What is the length of the hypotenuse of a right triangle with legs 9 centimeters and 12 centimeters? So let's draw that out. There we go. We'll say 9 and 12, and I don't know. So in this case, again, c squared equals 9 squared plus 12 squared. So c squared equals 81 plus 144. So c squared equals 225. So c is the square root of 225, which we all know is 15. And don't forget the label of centimeters. Sometimes we'll be asked to find the length of the leg. So I know the hypotenuse and one of the legs. Got to know that much, right? So a squared plus b squared is c squared. So 5 squared, Richard, is 25. Still don't know the b, that's squared. 13 squared is 169. Now here's the thing. Notice here, I have to subtract. We aren't just going to add. We're going to subtract that 25 from both sides. So b squared is 144. Square root of 144 is 12. So 12 centimeters in this case for the other missing side. Ooh, that's a Pythagorean triple, isn't it? Oh, I already have one here for us to work. So we end up with 15 squared, that's the hypotenuse, equals 12 squared plus a squared. So 225 equals 144 plus a squared. Subtract that 144, a squared equals 81. So a then is 9. And there you go. That's solving for a leg. Okay, so finally we're getting to that idea, the converse of the Pythagorean theorem. In other words, if I give you 3 lengths and at random, do they make a right triangle? And so let's take a look at our examples here. And again, please remember the longest side is always going to be the hypotenuse if it works. So here we have 6, 24, 25. 6 squared plus 24 squared, does that equal 25 squared? No, the left side is 612, the right side is 625. 4, 8, 10, same thing. 4 squared plus 8 squared, does that equal 10 squared? No. We could try it with 10, 24, and 26. Again, the 26, if it works, has to be the hypotenuse. 10 squared plus 24 squared, does that equal 26 squared? We find out yes. And then finally one more, 8 squared plus 15 squared, does that equal 16 squared? And we find out no. Again, when it's no, it does not make a right triangle. If it's yes, it does make a right triangle. So here, could the lengths 24, 47, and 52 be the side lengths of a right triangle? And we can see I've already done that here. So that gives us 20 squared plus 47 squared. Does not equal 52 squared. Again, you can put that into your calculator and prove that here. So no, that is not a right triangle because it does not satisfy Pythagorean's theorem. B, if A and B and C satisfy this equation, are 2A, 2B, and 2C also possible side lengths of a right triangle, and how do you know? Well, it is yes, and here's how we do, because we know how to work with exponents. So 2A squared plus 2B squared plus 4, does that equal 4A squared plus 4B squared, right? It does. Now, what we're really asking then, Does all that equal 4c squared? And the answer to that is yes. So again, here's what we're looking at. Let me write it out just to make sure we've understood the idea there. So if I have 2a, and again it has to be the whole thing squared, not just the a, plus 2b, the whole thing squared. Does that equal 2c, right, the whole thing squared? And so here we're going to have with 4a squared plus 4b squared, and again that is 4c squared. And our question here then is, can we get back to a squared plus b squared equals c squared? That's really what we're looking at, proving that that's the same, that it still works. And we've learned enough about factoring, right? So if we factor out here, we get 4a squared plus b squared equals 4 times the c squared. Divide off the 4 from both sides, and guess what? We're right back to it. So it did not change a thing, so yes, it does still work. And that's not something I want to make you prove. It's just kind of an exercise in thinking. Give you the chance to, hey, can I wrap my brain around this?